on the board. Probably would be easier.
First word.
All right, so when you look at that image, most of you have, no one's told me they're blind in one eye. So each of your eyes is seeing that image. Everybody get that? Okay, so if you close your left eye, you're still seeing it. If you close your right eye, you still see it. So this is what's known as the visual field, what your eye actually sees. So here is the retina of your left eye with the optic nerve. Here is the retina of the right eye with the optic nerve. And so I'm going to put the visual field for each eye up here. So both eyes are looking at that. So this eye is going to see the same image, and this eye is going to see the same image. Okay? So all I'm saying here is that the left eye is seeing this and the right eye is seeing that. Remember, the image is processed, reversed, left to right, and top and bottom. Top and bottom is going to be the same here. So this is known as the medial or nasal retinal field, meaning where the photoreceptors are. And this side is lateral or temporal retinal field. Same over here. This would be the lateral. Or temporal. So we're not going to worry about the fovea centralis and all of that. We're just going to do the crisscrossing. So this is going to be processed. It's medial, but it's processed by the lateral aspect of the eye because, again, the images are reversed. And that's going to activate photoreceptors and then bipolar cells and then ganglion cells. So this cell that I'm drawing into the optic nerve is a ganglion cell. And it's going to come back and synapse in what group of nuclei? The lateral nucleus of the thalamus. What was our rule? So this is actually our second order neuron, right? And what was the rule that we had for the second order neuron? They always, almost always cross. Here, half of them will cross and half of them won't. All right, so the ones that are coming from the lateral retinal field will will not cross. The ones that are coming from the medial retinal field will. So that's going to activate secondary neurons that are going to cross over. So this is the optic nerve. This is the optic tract and optic chiasma. Do the same thing for this one, the light waves that are processed here. Cross over. Light waves that are processed here do not. Third order neuron cell bodies form the thalamus and go to the primary visual cortex and the occipital lobe, which I foreshortened here because my board ended. Same thing here. Third order neurons go to the occipital lobe for processing and creation of the image. Notice what happened to my visual field. The left half of the image is being processed on the right side of the brain, and the right side of the image is being processed on the left side of the brain, even though only half of my second order neurons crossed. The processing of the entire image has crossed. Okay? So now let's look at what happens if we cut these fibers. So with normal vision, each eye is going to see the same thing. The field of view is going to be identical. Oops, I did it reverse, sorry. Isn't it cool that while I'm doing this, all your eyes are doing exactly the same thing, processing all these images? All right, so now if I cut the left optic nerve to create lesion number 1, it's easy to figure out you're not going to have an image in your left eye, right? Just close your left eye. All you're seeing is what the right eye sees. So we'll have, for lesion number 1, we will have no image in the left eye, and the right eye will see normally. So if I'm looking at this image on the board with both my eyes are creating that image. If I close my left eye, my right eye can still look at it and see it. Okay? Both eyes would have focused on it, but now my left eye isn't working, my right eye is still going to look at that image and see it. All right. Now, let's cut the optic tract instead. So lesion number 2 is cutting the left optic tract. So the best way to figure out how the image processing is affected is to follow the source of the electrical impulses out to the field of view and block them. So this one comes from here. This one comes from here, and that's my field of view. The temporal field of view for my left eye, the medial field of view for my right eye. Okay, you see how I did that? Just follow that back, block it out, follow that back, block it out, and that's what you see. So for lesion number 2, at the optic tract, I am only going to see that view for each image. Okay. So if my optic tract was cut, and my left optic tract was cut, and I was looking at this image, all right, the only thing I would see would be the left side. I'm focusing at the image, and I would only see, this says right eye because it's looking up from the bottom. I'm looking down from the top, so don't pay attention to the left and the right. I would only see this, okay, because the opposite side is being processed, the right image is being processed in the left side of my brain, and it's not getting there. So when I look at this, if the left optic tract is cut and I'm looking at that image, I'm only going to see this area. All right? Now if I shift over, I can see that, but if I'm focusing at the whole thing. Now let's say that I have a pituitary tumor. My pituitary tumor has gone haywire, and it's grown up and out of the sella turcica, which is right at the optic chiasma, and it's pressing up on the optic chiasma. It's the only time pituitary tumors typically are dangerous. And so it's going to press right here in the center. And those nerve fibers are going to be killed. Okay, so lesion number 3. Again, the easiest way to figure this out is to take each of those neurons and follow them to their source and block them. Tunnel vision. Periphery, narrow down. I can see both the green and the blue, all right, but I can't see periphery. So one eye is seeing green, one other seeing blue, so I get the both object, but I have tunnel vision. I can't see to the side. And so if I were to put that up on the screen, on the board here, I would see that with my left eye, and I would see that with my right eye. So the black lines show where the vision is absent. We're done. So let's take a break till 1.